we bought this instrument about 4 or 5 years ago. And we were very excited about that because we could have our own benchtop TM instrument where we could screen all our samples, like a little bit like a dynamic light scattering experiment. And I want to say that we have in our department access to a TM facility with, a conventional TM at higher voltage. But it's a completely another thing to have something that you can have in your lab, and it's actually the maintenance, not really something that is kind of costing or like time consuming, and also the preparation of the sample, or actually the handling of the sample in the to place it in the instrument is not very different from a normal TM. I would say even easier. So basically, it's a completely different thing. So basically, you have an object that, as actually the expert said before, you cannot actually expect to have the same resolution or the same penetration that a high voltage instrument. Also, the cost is quite different. But for sure, it is really important. For us, is really an asset for our characterization of the morphology of our materials. We are a lab of bio-nanomaterial supramolecular chemistry, so we actually work with a very different kind of materials, and the instrument is based on our lab, but actually we also the department contribute to buy it, so it's can be used also by other groups in the department. I just want to show you some of our image that has been taken by not by a specialist or a technician, but just by our PhD student, just to show you that it's really something that I wouldn't say all the master student can use, but if you do a good training and you have someone that is interested in what in his sample, like a postdoc or a PhD student, that of course has a kind of responsibility. Yeah, it's really not difficult to use. So this is something that we publish, and they are actually polymeric nanoparticles, so PLG nanoparticles. And what I want to say that this image have been taken without using any staining. So it's, as you can see, with the low voltage, you can have actually an improvement in the image of organic matter. And the size is about 100 nanometers. So it's they are actually also enough big. And so here the penetration was not a problem, mostly because I think is they are kind of spread on the grid, while what was saying the specialist is that you can have sometimes problem if you have films that are quite thick, and then in that case is actually impossible to measure. But if you dilute your gels, so if you in some way can you reduce the thickness of your sample, is actually possible also to image peptide networks, and this is our image of peptide gels that quite viscous sample. And actually we didn't, I mean, if you go too high in the concentration, you might have some problems, but if they are enough dilute and they keep their structure, you can actually measure with our instruments. You can also go quite in higher resolution. In some way, you can have also image like this, where you can study the nucleation sites, and we could do some dynamic studies that were quite interesting for us at different time of preparation. And then also, as I think, of course, if you use nanoparticles that are of metal nanoparticles that are not too big, you can also have a nice image of actually a supramolecular object, hybrid object. For example, on the here you can see on the on the top left, peptide fibers, where we, with some supramolecular chemistry, we could attach chemically some gold nanoparticles. Actually, here they were really synthesized on top of the peptide, and so you can see that you have some triangles and some spherical nanoparticle. And here we have some gold rods and some aggregates of nanoparticles, for example, that didn't actually get out what we wanted, but just to show you that, I mean, for us, it's really kind of an instrument that we use as a screening instrument. So we can image quite a high number of samples in a day, and then, I mean, it's just that you use a grid, and then you can choose the best samples if you want to have some higher resolution on tomography image in using an instrument that is, of course, more powerful. But then you don't have to do the screening, and so we know that it's quite expensive to measure at EM facilities. But you can choose and screen your sample in your lab with your time without, I mean, any actually cost afterwards. And this on the bottom, we have some, actually these one are proteins that in some way kind of form some complexes with the nanoparticle, and we see that we have also some free nanoparticles on the background. And the last image I wanted to show you are also fibers made by amino acids, so that they self-assemble to form these kind of fibers. And we have a very nice image of them, and these are quite easy sample to actually focus